All right, well, I'm going to be talking about agriculture, a small topic of global change, a significant driver. Driving global change for 10,000 years and still going strong. I want to start also by acknowledging John Katzenberger, who played a pivotal role in my 2-year post-undergraduate walkabout and was an excellent mentor in thinking about biogeochemistry and ecosystem ecology in enclosed human-managed ecosystems. And that went a long way towards propelling my curiosity into graduate school, and I'm very indebted, John. So we'll be covering some of the same ground today. I can't think of a single human activity that causes more global change than agriculture. The range, greenhouse gas emissions, appropriation of net primary productivity, habitat destruction, introduced species, freshwater appropriation, biogeochemical imbalances, depletion on the one hand, eutrophication on the other, erosion and sedimentation, not to mention the introduction of biocides into the environment. It goes on and on. And I put up a couple of my mentors, Bob Howarth, my PhD advisor at Cornell, whose work on marine and freshwater eutrophication has been very important, along with other work more recently, and Peter Vatusik. Peter, I believe, was at least co-host of the first AGCI meeting in 1992. That's right. That I was attending, and then one more recently on nitrogen in 2008. The reason we went down the path of annual agriculture is fascinating. But among the reasons why we did it are not improvement in ecological resilience or sustainability. And I think that's really important to remember when we're thinking about trying to improve this agroecosystem. Over the last 10,000 years, and particularly in the last 100, we have managed to change our agricultural practices significantly. We now apply fossil fuels to address virtually every ecological limiting factor to plant growth in agriculture. And we have also succeeded at using fossil fuels to replace labor, at least in developed countries, and increasingly in less developed countries. And the economics in this simple illustration are obvious in why it would make sense to do that. This results in a juxtaposition of agricultural energetics that's just mind-blowing. Comparing a pre-fossil fuel traditional Mexican farming system for maize with an industrial maize agricultural system in the US, caloric input per hectare about 642,000 calories. The traditional system about 10.5 million in the industrial system. Percent of energy derived from fossil fuels, well, zero by definition in this one. 99.96% of the energy to grow the maize is provided by fossil fuels now in the Midwest. Caloric output, about 6.9 million in the traditional system, 26.6 in the industrial. And the energy return on investment, about 10 or 11 to 1, and that 1 being a solar input, sunlight captured in the food that, for animal and human work, versus 2.5 to 1 in the fossil industrial system. So we've become homo petroleus, in a way, in our agriculture. No longer does agriculture have to pay for agriculture. So the practices of agriculture have changed dramatically, and especially because of fossil fuel inputs recently. But at its core, the ecosystem of agriculture is almost the same as when we started. And I want to spend a little bit of time with you all having a group epiphany about this. If you haven't had it already, many of you probably already have. I had about 8 slides that followed this. I took them out because I wanted us to come have a little thought experiment here. As an ecologist, this is horrifying, this landscape. And I'm curious, if you can think of anything that is particularly compromised in terms of ecosystem function, ecosystem services in this landscape. Some of them are obvious. What are they? Everything, but
Carbon sequestration.
what carbon? Okay, so carbon sequestration. When you till, on the order of 30% of the soil organic matter or carbon goes away up into the atmosphere, up to 50%, 60% in some cases. That's because microbes are stimulated, but it's also because you're replacing crops that allocate about 15% of net primary productivity below ground from crops or from species, perennial species, that allocated about 50 or 60% of their NPP below ground. Biodiversity. Do we need to say any more? I mean, it's utterly displaced the biodiversity that was there before. And if we fast forwarded this landscape 6 months, there would be one genotype covering it. So biodiversity, soil carbon, what's another? Runoff. So runoff carrying nutrients, runoff carrying soil. Soil erosion is obviously a problem on this landscape, or can be. Montgomery, in his PNAS paper, 2007, estimated that median global erosion rates from this landscape exceed soil formation rates by 90-fold. On plowed land. On no-till, by 4-fold. But still by 4-fold. Only the native vegetation had a soil erosion rate less than the rate of soil formation, which is why we have soil. But it underscores the fact that in many, many landscapes, the only reason you can have agriculture, annual agriculture, is because the soil capital was built there before by native perennial vegetation. And we have been drawing it down gradually ever since. One very important last one.
Surface atmosphere energy exchange.
Ooh, okay. That was a good one. It wasn't the one I was thinking of, but obviously the change in reflectivity and hydrology that goes with this elimination of vegetation is key. Oh, come on now. Nitrogen. I mean, going into Bob Howarth's lab, I learned very quickly what they think of agriculture as a source of nutrients that's eutrophying aquatic waterways. 30 to 60% of nitrogen is still lost, is not taken up by the crop in this ecosystem, in our food-producing ecosystem. And that's in some of the lands that have the best agricultural science applied to them in the world. We're not talking about a hillside in Bolivia or Indonesia, we're talking about Iowa. Still, we're losing that much. And my point here is that it's in the very nature of this ecosystem. It's compromised. And so much of the discussion in terms of agricultural intensification or ecological intensification, sustainable intensification, how we are going to feed the planet by 2050, huge topic right now, is accepting this as the starting point for the agriculture that needs to exist in the future. And in the same way that we have talked about decarbonizing our energy system and how much time and work that's going to take, there's a group of us that are thinking, we need to start over again with this as well. We can't, why begin with this, especially with the science that we have now? And so just to underscore, Foley is making some excellent statements right now about where we need to go with global agriculture. But these two, grow more on farms we've got, close the world's yield gaps, and use resources more efficiently, essentially doing more with less on this landscape is problematic in the long run. I'll skip that. So essentially, we are suggesting to move agriculture down a successional gradient to where we actually have much higher soil protection, much higher carbon and nutrient retention. And one thing I didn't mention, that it's not surprising actually it didn't come up, but in this field, the one other thing that happens is weeds. And weeds are plants that are evolved to take advantage of unused water, nutrients, and sunlight. And this is about the largest welcome mat you could possibly invent for weeds. It's a natural consequence of this landscape. If you have a perennial landscape that comes up, May 7th every year, the possibility of weed infestations goes way down. They are a consequence, not entirely, but largely a consequence of this ecosystem. So how do we do this? How do we come up with an agriculture that is further along in ecosystem development from the state of highly disturbed soil that we maintain indefinitely in our current agriculture? Well, one, as was mentioned, is to increase crop diversity. And a lot of people are getting behind this, either through conventional integration of diversity. Some are interested in using genetic engineering techniques, but essentially to look at natural systems and understand much more deeply how complex the ecosystem is and try to integrate some of these things into our agroecosystem to eliminate nematicides, to eliminate nitrogen fixers, to eliminate nitrification inhibitors, all of the inputs that we're currently trying to use to manage the compromised version of this. But the other one that my group is particularly intent on is the development of perennial crops. This is a silphium, an oilseed crop that's being bred at the Land Institute. And the roots are remarkable. And this plant did not blink in 2011, 2012, when the Great Plains was going through a fairly extreme drought a couple of years. And that we started working on it a lot more after that. Without the roots, diversity alone in annual crops will get us somewhere. But without changing the hardware, it's kind of like building a laptop using old hardware, okay? You can do it. You can do it. But boy, it's cumbersome, and it does not work nearly as well as hardware of a perennial ecosystem. And so, where am I at in time? I'm winding down here.
12 minutes of your 15.
Oh, very good. Wow. There's two approaches that we're taking to develop perennial crops. One is focused on the development of new crops, something we haven't done very much in the last 10,000 years. It's remarkable, actually. An oilseed crop, silphium, and two members of the actual sunflower genus, Helianthus, are being domesticated, as well as a relative of wheat, Kernza. It's an intermediate wheatgrass, and I'll show you a picture of it in a second. So this is very much traditional domestication, much like how Native Americans bred the sunflower from very, very small seeds. This is the annual sunflower relative from which sunflowers were bred, resulting in this constant selection. Only we can do it much, much faster. Both because of modern breeding techniques, we know what we're specifically doing, as well as using various molecular tools to help guide the breeding process. So here's two of the candidate species we're working with right now, moving towards a larger, an oilseed head that will ultimately, ideally, replace annual sunflower in the Great Plains. This is the Kernza, the intermediate wheatgrass. It's a breeding nursery, so all the plants are spaced individually. All are GPSed, all are barcoded, and every single one is evaluated individually for a range of domestication traits, non-shattering, evenness of maturation, and other aspects of crops that we'd like to see. The other approach is wide hybrid crosses, wide hybridization, where you take it's essentially perennializing annual crops we already have. And we're doing this with wheat and sorghum in central Kansas. And there's a project in the Yunnan province that they picked it up from Erie on a wide hybridization of perennial rice. And then once we have the hardware, we're taking the very preliminary steps of starting to grow them in various combinations to access ecosystem services such as nitrogen fixation in an intercropped legume, but many, many others. There's all sorts of work being done on the below ground efficacy, the microbiome that undergirds perennial plants as opposed to annuals, and it's a very interesting area.
That's 15, so you're in your Q&A period now.
Okay. We're not doing it alone. We have a whole cadre of collaborators in the U.S. and around the world, and it's a not Pollyannish, but it is optimistic. It's fun to work on a project that is actually, a hopeful solution that along the lines of a little bit of the repair of the reef. So with that, thank you all. Happy to take a few questions. Yeah.
I had a quick question about your energy return on
Investment.
yeah. So I assume that's like a typical farm, so it's not a best practice. I was wondering if you knew offhand best practice, what that would be for industrial farming.
I haven't seen those numbers generated since best practice times. I would suspect they'd go up a little bit with lower fertilization in particular. Have you?
No,
Yeah.
I was just really curious.
Yeah.
It was kind
2.5. I've seen them lower than 2.5. That's actually fairly generous, but I wouldn't be surprised if they could be a little bit higher than that.
And just another quick
Yeah.
question. I was surprised you didn't mention farm policy.
Yeah. Well, my title did.
How much of these problems do you think is just a reflection of our agricultural policies?
See, most of the problems I described are inherent in annual agriculture itself. Now, addressing it will definitely involve farm policy and the extent to which more research is generated and then rapid deployment of these species on the landscape, incentivizing that through crop payments and certainly dismantling the crop payment structure that we have out right now that maintains corn and soybean across the upper Midwest will be essential. But I did leave that open for discussion further in the week. Yeah.
Yes.
In the research you're doing, do you have a parallel set of research which looks into the marketing of some of these new grains? I'm always come back to what we were discussing earlier, the sorghum issue in India, but also one of the projects we had in Southeast Asia, where it's obvious that people's chickens are being washed away in all the floods. So the obvious thing is that you raise ducks instead.
Yeah.
But ducks don't work as well in certain Vietnamese
Yeah.
cooking, and therefore gone.
We're taking very initial steps towards marketing that Kernza grain as a kind of specialty grain in the U.S., and that I think will come in fairly easily, kind of like quinoa or something. It's not the long-term goal, but it's putting some training wheels on. More interestingly, though, you might have seen collaborators in Africa, and the Gates Foundation is funding a scoping study right now to try and evaluate receptivity of perennial sorghum in particular, while we have the germplasm being grown out to even see what it does in those conditions at Ikrasat in Mali. But absolutely, most of the crops aren't that close, unfortunately, to make those studies. But it's never too early, probably, to start inquiring.
Did you have a question?
Yes,
Okay.
yeah. I really like your presentation, and I would like to follow on the question on policies
Yeah.
and politics, and to ask you whether you have thought about the possibility of working with social scientists on this, because this is not only an
Yeah.
issue of how cool the techniques are, which for sure they are very promising, but also of behavior and of incentives, and people are moved by things, what are their preferences, what is the structure of
Totally, yeah.
economic incentives, and I really think this is a beautiful example of the kind of interdisciplinary research that needs to happen, whereby it's not only your group, but it's a bunch of other groups that are needed
Yeah.
to be at the conversation you need to get started.
It's a great point. In terms of the social science, there's a University of Kansas group that is looking at some of the questions, but very recently, Lennart Olsson in Sweden is put in a proposal to do some of the social science work on this.
I guess I was wondering, a lot of the presentation was how to kind of mitigate agriculture's impact on global change.
Yeah.
But how do you see those strategies being impacted by future impacts from global change on agriculture?
Yeah. So in other words, how would a perennial agroecosystem function in the face of as an adaptation? Well, we also are working on this, and people often who are, the Pollyannas out there will say, oh, it's more resilient, it's going to do better, it's perennial. And I mean, the reality is these crops have higher net primary productivity and use more water than the annual crops. Now, that said, one would, in many cases, there's going to be higher infiltration rates into a perennial stand, very much less runoff and surface evaporation, A, and B, the crops can appropriate a much larger soil volume of the water that is captured. But all that said, it's going to be a soil texture, climate-specific, crop-specific set of answers to that question, and obviously it's critical. I can envision scenarios where they do better and where they do worse, to be honest.
Last question.
Yeah.
I was at a meeting last week at Iowa State University,
Yeah.
with Jerry Hatfield was running, that was looking at temperature effects on crops, and I came away shocked by how little we know about how crops are sensitive to climate change and all the factors that can affect that. But also another interesting thing is as we start having larger water problems in the West, and California maybe isn't the source of vegetables and fruits like it is now, there was talk that, well, maybe that can just all shift into the Midwest and we'll just and really change the whole nature of agriculture in the Midwest, and it was like, whoa.
Even still, vegetables comprise not much more than 2% of our of our cropland.
Yeah.
Most of it's under grain, pulse, oil seed, fiber. But yeah, I mean, probably not Kansas, but maybe Iowa. Yeah, and Illinois for sure. Yeah. All right.